be talking about HP's efforts in the persistent memory area and what they're doing going forward. So let's welcome Alex.
So yeah, we're going to start off and explain that HP is a big company. We're working on a lot of different initiatives. One of those initiatives is Memristor. That group is sort of a partner of my group. We're looking at them sort of as it would 3D Crosspoint or any of the other resistive RAMs and phase change memories out there. So we're looking at bringing sort of all these types of persistent memory solutions to market on ProLiant servers and finding the best way to do that. So I wanted to start off with the same kind of slide that we've seen in 4 or 5 different ways now. One thing to mention is sort of cost. And cost we can also look at in terms of capacity, right? When we have a denser memory die, generally we can drive the cost down. And when we have a less dense memory die, we have a higher cost. So today in the market, we've got DRAM technology that we can build things out of, and we've got Flash technology we can build things out of. And there's all kinds of stuff emerging, right? You talk to any of the big memory manufacturers and some other players, and they're building all kinds of stuff sort of in this space. But when we survey the industry and we look around, it's important to note that nothing that's coming and nothing that's out there is universal memory, right? We would love to have something that's as fast as DRAM and has the persistency of Flash and the density of Flash, but nothing is that good, right? Everything is kind of up in this general space. And so because of that, we see some market segmentation happening, right? I don't think there's going to be a winner-takes-all, one persistent memory that comes in and everybody uses. If we think about use cases, there's block storage,
Your
right?
attention, please. The building emergency condition has been cleared. The building emergency has been cleared. You may return to your normal activity. Your attention, please.
All right, so yeah, I was saying, if we think about use cases, we can use this in a couple of different ways. We can use this as block storage, and we can have those big expensive storage stacks that Intel talked about earlier today. As soon as you start differentiating things by an order of magnitude, block storage, new types of block storage become interesting, right? So I think that leaves a lot of space in here for NVDIMM-Ns to participate, as well as 3D Crosspoint sort of things to participate, as well as potentially other types of memory mediums. Also, we can go from the other side and augment or augment DRAM, right? We're not going to replace DRAM, but we can start to build a tiered DRAM structure where we use, Diablo's doing some interesting things with Flash as memory. Some of these other technologies will again be used in the memory space. So both of those applications are important and useful. But really the third case, and the case everybody's been talking about today, is the most useful of all, and that's a persistent memory use case, right? That's where we're using this byte addressable nature of the thing. We're getting rid of sort of those software stacks, and we're able to access those latencies more exactly. And again, we see separation in terms of more performant solutions and less performant dense solutions in that space. We do have a problem with that, in that we need a way to interconnect it, and that's one of the problems that I think we as a group and we as an industry have to face, is how do we connect these mediums? I kind of disagree somewhat with the previous discussion around attaching on PCI. I think that's going to end up being too slow for a lot of the use cases we're looking at, and I'm not even sure that the memory technologies that are going to emerge in this space are going to be fast enough, right? I think that's one of the challenges, and so finding ways to build sort of cached architectures or using the NVDIMM-Ns in conjunction with phase change memories and other sorts of things, building solutions like that, I think is going to be very important moving forward. So this is a slide that's kind of similar to, again, the latency story, right? If you look at approximately the work we have to do today in order to save a piece of data, we've got to do, and again, NVMe or different sorts of protocols might drive down these numbers, but one estimate would be 25,000 instructions and 5 data copies as you move, down through the file systems and buffers, and you have cache on the controller, and then you eventually get down to your memory medium. If we can kind of cut through that, right, and work as an industry to develop these new libraries and these new ways to have these byte addressable storage instructions, we can cut that down to 3 instructions or a handful of instructions in order to do those saves. This slide shows some more important things. So one is up in the application space. So we've got objects and we've got interpreters and libraries and software as a whole, right? And it's very complicated and there's a lot of things going on there. And as this moves forward, what we're seeing as we start to work with ISVs in this space is the software changes, but in a lot of cases the software is actually simplifying. Right? If you think about how a database works and what you have to do in order to make sure you have persistency and consistency, you have to go out and you have to do buffer writes, and you have to log things, you have to do all sorts of operations in order to get that consistency. If we have a big pool of persistent memory and we can do those in-place updates, the way we change the software is we can go out and we can cut out a lot of that code that's going and taking care of some of that persistency and consistency semantics. So because of that, what we're sort of seeing is this adoption is taking place faster than we initially thought. Right? It's still, different segments are adopting things at different rates, but there's a lot more appetite in the ISV community to go and pick up some of these changes because of that simplification. The other thing you'll see here is that some of this stuff that we spend a lot of time in today, right, block drivers and those sorts of things, those kind of start to go away or change. They're still there, right? They're used for management, and we're working with JEDEC and with other industry standards to make sure that we can manage and use these things in a standard sort of way. One of the things HP is doing is driving differentiation there. So we're working with JEDEC to adopt industry standards, but then we're having vendor-specific commands where HP will have best-in-class RAS handling, best-in-class monitoring, and some of those sorts of things. And then at the bottom layer, the media we think is also going to be simplifying drastically. So the last thing I wanted to talk about was the sort of opportunities for acceleration, right? Everybody's question is, where is this going to be used? How is this going to be picked up? What kind of applications are going to really take advantage of this? And like I said, we and some of our partners have been working on some of this early adoption. And what we're seeing time and time again is databases and database-like applications is one of the early adopters. So a lot of those software stacks are able to take advantage of even those very small NVDIMMs, right? Using those as write buffers for incoming writes to drive down those latencies and unlock, the next transaction. So it's the latency that's really, really important there. We do think over time, different kinds of NVMs, right? The phase change memories and the resistive RAMs and the memristors and all these sorts of things will impact different application stacks in different ways, right? The in-memory database might not be a real great candidate for NVDIMM-Ns, but it might be a great candidate for 3D crosspoint, right? So that's some of that segmentation we're going to see is also by the addressable market, by the workload we're targeting. One thing to mention on here is a big important thing in the interim is middleware. So HP is helping work in some of these middleware layers, some of kind of what Amit talked about in terms of how do we make this transparent to the application, how do we change some of the stuff underneath so the application picks up these changes for free. So HP is working to define reference architectures, both when we're using these middleware solutions as well as with our ISV partners that are making those changes. So to summarize, I don't think there's going to be any universal memory, right? A segmented market. There's going to be many memories that are going to have many use cases, at least for a while. We need to have an open standard for how we connect these things, right? It's a big problem, and it's going to get bigger going forward as to how all these new solutions attach onto a memory bus or some other bus, something with low latency. These latencies are forcing software to fundamentally change. We've heard that again and again today. HP is innovating, right, through standards. We're defining reference architectures where we want to get in front of this. We want to work with you. If you have an application, if you're a customer and you're looking to set up a beta program, we have a beta program running where we're demoing hardware. The databases are going to be some of the early adopters. And yeah, we're ready to work with you. So feel free to come out and talk to me after the talk. I'd love to hear more about what you're doing with persistent memory. Thank you.
All right, thank you, Alex. So our last presenter on the NVDIMM panel is Marc Schneider. Marc is the Senior Product Manager at Supermicro. He leads the Intel Architecture Dual Processor Mother Group over there. He has launched multiple generations of award-winning data centers and enterprise products. He has over 25 years of experience in product management, engineering management, and product design. He holds a BS, BA in high-tech management from San Jose State University, and he's going to be talking about their latest developments, some of their platforms. I think they have 21 either storage and server platforms launched that support NVDIMMs. And he'll also talk about some of the developments with NVDIMM. So we do want to leave some time for questions as well, so we'll keep that in mind.
Thank you. Thanks so much. So today I want to talk about a few items. First, I'm going to glance over top level the NVDIMM advantages. I think most of you are familiar with this, so I'm not going to spend a whole lot of time on this slide. And then I want to go through our development updates, where we are with our motherboard products and also some of our storage products as well. And then talk about some of the next steps that we see happening. So starting off, of course, the technology benefits of NVDIMM. High performance because it's in memory channel as opposed to the PCI or NVMe type of solutions. It's a very cost-effective solution. Gets rid of UPS and batteries. We've launched a few products in the past with battery enablement. Feedback from the customers is very mixed about that. They don't like batteries. Batteries have a high maintenance cost over the lifespan. They usually have to change them out every 3 years. So anything that we can do to get rid of batteries, get batteries out of the system altogether, really benefits the customer. Reliability, of course, preserves critical data in the case of a power loss or a critical failure. And of course, compatibility. It integrates very well with all the x86 products and eco-friendly because it's lead-free. Checkpoint. So lots of applications for this kind of technology. So where are we today? Thank you, first of all, for the JAG community for doing all their hard work. It's really helped a lot with this technology. We've been working on NVDIMM since the DDR3 days with Romley. It's a lot of struggle early on because there were lack of standards, especially with the supercap charge times, but also in terms of the hand-holding that we had to do in terms of BIOS development to support these products. A lot of customization, a lot of man-hours spent to get this right. That has all changed with DDR4, with the leadership of both JEDEC and also Intel stepping up to the plate and helping us out greatly there with the new MRCs. So one of the big things, of course, I mentioned is the supercap recharge times. The new JAG standard, the 288-pin DIMM, which added 12 volts, greatly reduces the supercap discharge charge times. This is a significant improvement over DDR3. The save-in pin and the event pin definitions, as well as I2C addressing, all of these have greatly helped with BIOS development. What's new too is now JAG-defined SPD and registers to comply with DDR4 RDIMM. We have got several samples from all the major vendors in-house now, and we are looking at enabling JEDEC DIMM compliance in our future BIOS releases. And then lastly, the NVDIMM firmware interface pin, the NFIT, added to ACPI 6.0. From Supermicro standpoint, we've been one of the big leaders in this space. Our CEO, Charles Yang, really believes in this technology, as well as all the leading edge technologies. Supermicro has not only put a lot of effort into NVDIMM development, but also with NVMe technology as well. If you look at our product line, you'll find quite a few server enablements for all of these technologies. I'll go over some of them a little bit later. Right now, we're supporting 5 vendors, and those vendors are listed here. We're going to be adding a 6th very soon. We've just gotten their DIMM sample, and we look forward to adding them to the family of supported products. In terms of motherboards, I have over 20 SKUs enabled, And that translates into over 60 different server SKUs supporting NVDIMM, including 20 of those storage-specific solutions. So what are those boards? A lot of people ask me for this list, so let me go through this list really quickly. I broke this into the 6 segments that we see are really drivers for this technology. First, of course, is the channel. Supermicro began its life in the channel as a white box vendor, as a component supplier, working with distribution, VARs, and system integrators. We continue to hold a vibrant business in that segment, continue to be the king in the channel. So a lot of our products are used specifically to build storage solutions through channel providers. With that, we have both motherboard, we also have bare bones, bare metal solutions, or we have complete solutions, turnkey solutions that are available through the channel providers. For the enterprise, our X10 DRUI Plus, this is our new Ultra series. This has been a tremendous hit. We've just released this about just a little over a year ago, and we've seen tremendous sales on this product. It hit the sweet point with a lot of the data center and enterprise customers out there, and we've enabled NVDIMM on that from the get-go. HPC, we have our Twins and our Fat Twins solutions. We also have a new Twin Pro that's coming out. We'll be announcing that at the Broadwell launch in March. A lot of these are complete server solutions. However, the ones in purple you can buy as a separate motherboard. A lot of universities and folks in the science community like this because they can create their own enclosure solutions with the X10 DRTL. The new product coming down, the new Twin Pro, will be based on the X10 DRTPS, and this brings in some new I/O capabilities that I think a lot of customers will really like. Data center, we have our data center optimized line with the DRDs, the DRDLs, the IN and the TPs, the X10 DDW and the DRW, which are our WIO series. Extremely popular with both cloud providers and also general data center compute farms. Storage, we have our DRS, which is our latest version of the SBB that's coming out, or it actually has been out. This replaces our previous Romley generation. For those of you who are familiar with the X9 DBS, the X10 DRS replaces that. And we've launched the 2U and the 3U, and the 4U is coming. We have 2 new products, the X10 DSC and the DSC TP84S. Those will be in our brand new products that we're announcing. Also, we'll be showing at the Broadwell launch, and that's for our new 60-bay and 90-bay compute storage boxes. The DSC Plus brings dual E5 performance up to 160 watts with 24 DIMMs. Supports up to 60 SAS drives, as well as 6 NVMe drives as well. And then the X10 DSC TP4S, that's a tongue twister. That will be for our new 90-bay enclosure. That will be an 8-DIMM solution, also dual E5 2600, combined with a 90 drive, 3.5-inch bay. Okay. And lastly, we have our GPU series, the DRGQ, and we're looking at enabling several other products as well as time goes on. The good news is that all the X10 products at the hardware level are ready to go as far as NVDIMM goes. ADR trigger's been enabled on all of them, so for us, enabling any one of our available SKUs, we can do that through BIOS and BIOS alone. Okay. Going on to the system level, we have several storage products available in various different configurations. We have systems available for both hardware RAID and also in IT mode in various form factors, 2U, 3U, and 4U, as well as we have a pair of our single processor solutions available as well. Just about. Okay. Calls to action. This is some of the feedback that we've gotten from our own customers working with various folks out there. One issue that we've heard from several customers is that they would like to see data encryption with password locking on the DIMMs. That's one thing I think that would be nice that the JEDEC folks might be able to help out with there. From an OEM perspective, from a development standard, we do not see a standardized set of OEM automation and diagnostic tools. We would like to see that. It would make our life a lot easier. Right now, we have to use a lot of customized tools from each one of the vendors. In some cases, the vendors themselves have to do the validation. So that's made it a little bit difficult for us. Improve supercap performance, size, and cost. As you can imagine, especially when you get into the twins or fat twins. When you get into the twins and fat twin series, we're packing a lot of compute hardware in a very small box. There isn't a whole lot of room in there to put a whole lot of supercap technology. So what we need is some innovation going on in that area, and I'm happy to see several of the vendors are stepping up on that. But also in terms of the cost, we need to drive the cost down a little bit more on that to bring it a little bit more in line. On the software side, better OS recognition of the new APCI 6.0, the NFID, to really help the end user application development. In our position, we offer consulting services. We can't really help the end user in terms of developing their applications. We have to work in conjunction with the NVDIMM development community to help them develop their apps. So while we've got BIOS enablement and hardware enablement solved, the last mile, of course, is helping the end users. And I think this has been a struggle. It's been a roadblock in adoption. There certainly is a lot of interest from what we're seeing in this technology, but I think the long road of development time and cost and time to market is impacting a lot of these folks from making the jump. And lastly, to go along with that is to see standardized NVDIMM seed libraries, again, to help speed up the development cycle. Okay, and that's all I've got. Thank you.
Sorry, those turned on over there? Are those mics on over there? All right, just a couple questions. We took a little bit too much time, unfortunately, so questions.
Yeah, there was some mention of BIOS support. So what is the status like of UEFI support, the NVDIMMs and issues like that?
It's there. We're right in the process right now of releasing our...
Sorry, did everybody hear the question?
Oh, sorry.
Regarding BIOS support on the NVDIMM-enabled systems.
Yeah. So, yes, we have it. We've had it since Haswell launch. But we're right now rolling out our 2.0 BIOS, which will support Broadwell as well, and those are fully UEFI compliant with NVDIMM. What's not quite there yet is the support for the JEDEC NVDIMMs yet, but that's coming.
Question over here? Yes.
Oh, yeah. Do you anticipate rolling stuff out for supporting the Intel PDX-1? Same kind of thing, or?
And that question applies to Alex as well.
Yeah. From Supermicro standpoint, absolutely. Yes.
Yeah, from HP as well, we'll be there with 3D Crosspoint at launch.
Question? All right. Well, thank you. Thank you very much for taking time to be on the panel. Thank you, everyone.
Thank you very much, Arthur, not only for pulling the panel, but for all the hard work you do. You know,